All right, let's do an example of solving an ODE with repeated roots. So let's try to solve y double prime minus 6y prime plus 9y equals 0 with initial position 1 and initial velocity minus 3. So just as before, we need to find the roots of the auxiliary equation. So r squared minus 6r plus 9 equals 0, which is a perfect square. So r minus 3 squared equals 0, and therefore r equals 3, which is repeated. And what this tells you is that y of t is ae to the 3t plus bte to the 3t, because we have a repeated root. And then all we have to do is plug in the initial condition. So y of 0 equals 1. That tells you ae to the 0 plus b0 e to the 0 equals 1. And this nicely simplifies simply to a equals 1. So basically, y of t is e to the 3t plus bte to the 3t. So that's one thing. And then we want to plug in y prime of 0. So let's differentiate y. So y prime of t is 3e to the 3t. And then for bte to the 3t, use the product rule. So be to the 3t plus bt 3e to the 3t. And in this case, y prime of 0, that is 3e to the 0 plus be to the 0 plus b0, 3e to the 3t, 3e to the 0. And the nice thing is this just simplifies to 3 plus b. And we know y prime of 0 is minus 3. So b is minus 6. Minus 6. So a is 1, b is minus 6. So y is e to the 3t minus 6t. E to the 3t. And in fact, if you draw the graph, there's a little bit of an extra problem, then you may notice that slightly before 0, it actually attains a maximum. So this is why. And the question is now, where does this function attain its maximum? So where does y attain a max? And in this case, from calculus, all you need to do is set the derivative equals 0. Set y prime equals 0. I know we also need to set the second derivative to be negative, but in this case, from the picture, there is a maximum. So let's calculate y prime. So y prime is e to the 3t minus 6t e to the 3t prime. Or you can use the formula for y prime of t from before. So that becomes 3 e to the 3t minus 6 e to the 3t minus 6t, 3 e to the 3t. And I think that simplifies to minus 3 e to the 3t minus 18t e to the 3t. And that's minus 3 minus 18t e to the 3t. And you want to set this equal to 0 because you want y prime to be 0. And in that case, you can divide by e to the 3t because it's never 0. And you're left with minus 3 minus 18t equals 0. So t is minus 3 over 18. And that's minus 1/6. So roughly minus 0.1667. So in fact, slightly before 0, the function attains a maximum.